Her name is Laura Alicia Orozco. She's she's doing her PhD in the University of Chihuahua. Laura Alicia, if you could share your presentation with us, please. Yes.
Can you see it?
Yes.
Okay.
Thank you. So you have 15 minutes and then a couple of minutes for questions, okay?
Okay. Well, hello everyone. Thank you for returning from after lunch. Today I'm going to present you a part of my thesis. It's membrane systems for the recovery of phenolic fractions from grape pomace. And to get in to be in context, why grapes? Well, both the weather and the soil of the region are favorable for the cultivation of grapevines and winemaking. Right now, there are 32 vineyards that are established along 12 municipalities throughout the state. And as a consequence of winemaking, we have grape pomace. Grape pomace represents around 20 to 25% of the original weight of grapes. It's mainly a solid waste that is obtained after the grapes have been pressed. And it's made of skin, pulp residues, seeds, and occasionally it contains stalks. There you go. Well, skin is made up to the 50% of, represents up to 50% of pomace. It's characterized for having a high polyphenol content and mainly anthocyanins that have a degree of polymerization that goes between 20 to 80. If we're talking about red grapes, we have also the process of anthocyanins, delphinidine, cyanidine, petunidine, peonidine, and malvidine glycosides. And anthocyanins are known for being the most important group of water-soluble pigments in the BIS region. Their colors go from red to blue. They're pigments with added value for human consumption due to their antioxidant capacity, and they're known for being stable at acidic pH values. Currently, there are 26 FDA-approved natural pigments, and 4 of them are actually obtained from grape. We also have seeds, and they have condensed tannins, but in this case, they have a lower degree of polymerization. They are around 11, and there is no presence of anthocyanins in seeds. We can see on the top right a general structure of an anthocyanin, and the hydroxylation and methoxylation patterns we can see here R1, R2 are going to determine the glycon and the anthocyanin that we have. We have a key R3, and that can be a glycosylation on the C ring. This glycosylation increases the stability and water solubility. And when it comes to Vitis vinifera, or the grapes that are used for winemaking, R3 is going to be a glucose. It can be that the sugar residues are also acetylated, whether it's with acetic acid or p-coumaric acid, caffeic acid, and this acetylation decreases water solubility. We also have anthocyanins, as I told you before, they're present in the skin, and they're known for being water-soluble phenolic compounds that have a molecular weight that goes between 500 and 3,000, and they have the ability to precipitate alkaloids, gelatins, and other proteins. They are polymers that are made by monomeric units called flavanols, and they are linked together by an interflavanic bond. We have 2 types of interflavanic bonds. Type B is, we can see it on the top right. It's the link between C4 of the upper unit and C8 of the lower unit. We also have a type E interflavanic bond that is a doubly linked unit. In addition to having the type B interflavanic bond that I already mentioned, we have an additional bond that is between C2 of the upper unit and the oxygen-bearing C7 of the lower unit, as we can see on the top right, bottom right, I'm sorry. The objective of this work, it aims to use a membrane system for the recovery of polyphenolic fractions from grape pomace. And once we have those fractions, we are going to go forward with its characterization. The particular objectives are the stages that are going to allow us to complete the purpose of the work. And they are to obtain the phenolic fractions from grape pomace by means of solid liquid extraction. Once we have those fractions, we characterize them and quantify the different polyphenols present by means of HPLC in order to determine the polyphenolic profile. And we are also going to fractionate the polymeric extract using a membrane system. First of all, we had to carry out a solvent evaluation to determine which solvents we were going to use for the extraction. We evaluated them as one-step solid liquid extraction. It's a ultrasound assistant, and we kept the temperature of 2 degrees Celsius, solid liquid ratio of 5 grams per 50 milliliters. And you can see in table 1 the different solvent systems that we evaluated. There you go. We can see here in table 2 that the methanolic extract had the higher total polyphenol content, and it also had the higher anthocyanin content and flavonol content. So we decided that methanol was the solvent that we were going to use. We are trying to separate the compounds, monomeric compounds, from oligomeric compounds. So we also did something called an acid butanol assay that I'm going to present you after that. And here we can see the chromatograms of polyphenol content for the 3 solvent systems. We found 3 main compounds: malvidin trioglucoside, malvidin trioacetyl glucoside, and malvidin triocumaroyl glucoside. When I first told you about anthocyanins, I told you that they could be acetylations that decrease water solubility. That's the reason why we don't have as much malvidin trioglucoside as we have malvidin triocumaroyl glucoside. And as you can see in these 2 chromatograms and in the one that follows, it's the main compound that we have in grape pomace. Here is the 3rd chromatogram. Well, acid butanol assay is the assay that is going to allow us to know if we have proanthocyanins. And it's basically, we have the sample, we heat it in an acidic medium in order to break the interflavanic bond that I told you before. The breakage of this bond is going to release a red color that is based on the depolymerization of condensed tannins. And if the sample turns red, then it's positive for the presence of proanthocyanins. In my case, my samples are already red before being heated. So I need to take a measurement before and then make a subtraction, and the difference between absorbances is the thing that's going to tell me if I have a proanthocyanin positive sample. We can see it here. We took the measurements before heating and after heating, and all the samples were tested positive for anthocyanins. So we decided to carry on with methanol and to test the membrane system. It's a zero headspace extraction of phenolic compounds. And because of the configuration of the zero headspace extractor, we were able to separate the solvent of the solvent system that was chosen and to use it as a two-stage extraction. First, we were going to use water, acidified water with 5% acetic acid. And the second stage was acidified methanol, also with 5% acetic acid. The first stage goes like this. We have the grape pomace. We put the sample in the zero headspace extractor. We add the first solvent. We pressurize the reactor and we keep it shaken at 3 RPM during 24 hours. After that, we take the sample and we change the solvent. In this case, it's going to be methanol, and we repeat the process. After that, we're going to carry on with a cleaning stage, and then we go to determine total polyphenol content by means of Folin Chakalto, and again, anthocyanins presence by acid butanol assay. Here we can see a little bit of the reactor. At the end of the two extraction stages, we have something that we call cake. Cake is the spent grape pomace after we did both extractions. Here we can see in the blue table, we can see the quantification of polyphenols content for aqueous extracts, and in the bottom table for methanolic extracts. As we can see, we have tenfold a concentration that is tenfold higher in the methanolic extract than in the aqueous extracts. And we also did the acid butanol assay. We have a negative result when it comes to the aqueous extracts and a positive result for the methanolic samples. This means that the water extraction could be used as, let's say, a cleaning stage, because we suspect that we have phenolic acids in the aqueous extracts, and in the methanolic extracts we have anthocyanins and proanthocyanins. How can we tell that? Well, we did a total anthocyanin content and sulfite bleaching. Total anthocyanin content is 10 times higher in the methanolic extracts. And we also, that's why we only did the sulfite bleaching in the methanolic extracts. We can see here we tested two different pH values. At 2.5, we have 61% resistant compounds. And at 3.5, we have 82% resistant compounds. What I mean by resistant compounds? Well, we have this structure. If we have an anthocyanin, this reaction site that is the purple arrow points, it's free. So we can have the sulfite bleaching, and this reaction generates a colorless hydrogen sulfite adduct, which we can see right here. That means that we lose color in our sample. And if we have resistant pigments, this reaction site is not available, so this adduct cannot be formed. The reason why we have more resistant pigments at pH 3.5 is because at that pH value, some of the compounds that can be hydrated are already present in that colorless form. Therefore, the samples are more resistant to bleaching. I mentioned the cake before. we had some doubts if we had a complete anthocyanin extraction with the methanol stage. So we decided to have another extraction state using cake. We did it keeping the same solid liquid ratio. And this was to determine if we had anthocyanins. We can see here a total polyphenol content. We have a high polyphenol content, again, methanolic extracts, and the methanolic extracts from cake. So we have a considerable amount of polyphenols. And when it comes to acid butanol assay, we have also a positive result. That means that we have anthocyanin present in both methanolic extracts. We don't know yet if the presence of anthocyanins in the cake is because we didn't have a complete extraction at the zero headspace extractor, or whether it is because the membrane actually separated oligomerics from polymeric compounds. As conclusions, we have that methanolic extracts have a total polyphenol content higher than the aqueous extract, tenfold higher. I already told you, methanolic extract have a high percentage of sulfite bleaching resistant compounds. This means that we have a high amount of compounds that are either in an oligomeric or polygomeric form, or that are that don't have the reaction site available. When it came to the extract that we obtained from cake, it had a deep red hue. This means that it possessed an perhaps high anthocyanin content. And both the methanolic extracts and the cake methanolic extract presented that total polyphenol content that was high, considerable. So due to this, we have some next steps planned. We want to estimate the mean degree of polymerizations by means of fluoroglucinolysis of both the methanolic extracts. This is going to help us determine whether it was an incomplete extraction that gave us two different extraction stages with anthocyanins, or if it was in fact the membrane that separated oligomeric anthocyanins, that polygomeric anthocyanins.
Well, thank you, Laura. I don't think we have any time for questions, or maybe one quick question.
I have a question. Why did you use two different temperatures for extraction? In order to select the extraction solvent system, you used 2 degrees centigrade, but for the real extraction, you used 21 degrees centigrade. Is there any specific reason behind that?
Yes, the reactor is quite big. It actually measures around 30 centimeters. And we have a shaker that is specifically designed for the reactor. And we call it a coffin, that it's around 2 meters long and 40 meters, 1 meter high. So we didn't have a place to put it to keep the temperature at 2 degrees. We were able to keep the temperature of the room. That's why it's a little bit higher. We couldn't keep it at 2 degrees. And that's the reason why the configuration of the system didn't allow us to keep the temperature at 2 degrees.
Mm-hmm. Okay, so one last question real quick. What do you mean by cake?
Cake It's the little disc of grape pomace that we obtain after the both extraction stages. You can see it here at the right.
Okay, got it. Thank you so much.
You're welcome.
Well, thank you.